The remarkable Sylphian plant, once a sought-after commodity in the Mediterranean world, met its demise approximately 2,000 years ago. However, recent discoveries challenge this notion, suggesting that Sylphian may not have been entirely extinct. From the ancient Greek era to the peak of the Roman Empire, Sylphian held immense value. Renowned for its medicinal properties, it alleviated ailments ranging from stomach discomfort to wart removal. For Roman chefs, it was a culinary staple, elevating ordinary dishes like lentils and extravagant creations like scalded flamingos. During the reign of Julius Caesar, Sylphian was so highly valued that it was stored alongside gold in Rome's imperial treasuries, with saplings commanding a price comparable to silver. Despite its widespread cultivation along the coast of Cyrenaica, modern-day Libya, as documented by a chronicler in 638 BC after a black rain event, Sylphian vanished from the ancient Mediterranean world within 7 centuries. Roman chronicler Pliny the Elder expressed his dismay in his Natural History, lamenting the loss of only one stalk, which had been entrusted to Emperor Nero. Since the Middle Ages, botanical explorers inspired by ancient accounts of this extraordinary plant embarked on extensive searches across 3 continents, yet their efforts were consistently thwarted. Many historians regard the disappearance of Sylphian as the first recorded extinction of a species, plant or animal, serving as a cautionary tale of the profound impact of human consumption on the natural world. However, a recent discovery, made almost 40 years ago and supported by decades of subsequent research, suggests that a professor at Istanbul University may have rediscovered the last remnants of the ancient plant over 1,000 years after its disappearance from historical records. This finding places Sylphian more than 1,000 miles from its former habitat. Sylphian, often referred to as chemical gold, was renowned for its exceptional medicinal properties and culinary versatility. Its widespread cultivation and high value during ancient times made it a sought-after commodity in the Mediterranean world. On a sunny morning in October of last year, Mehmet Miski stood in the boulder-strewn foothills of an active volcano in the Cappadocia region of central Turkey. He gestured towards a thicket of grooved, buff-colored stalks shaded by wild pistachio trees. "Welcome to Sylphian land," the 68-year-old professor remarked, as he bent to extract a stalk and its gnarled root from the rocky soil. The root ball, the chemical factory of the plant, perfumed the air with a pleasant, slightly medicinal aroma, reminiscent of eucalyptus and pine sap. "To me, the scent is stimulating and relaxing," Miski elucidated. "It is understandable why everyone who encounters this plant becomes attached to it." Miski, whose field of expertise at Istanbul University is pharmacognosy, the study of medicines derived from natural sources, had initially encountered the modern plant he now believes to be the Sylphian of the ancients during his postdoctoral research 38 years prior. He had been granted a research grant to collect specimens of Ferula, a genus of flowering plants belonging to the Apiaceae family, which includes carrots, fennel, and parsley, and is known for producing numerous novel disease-fighting compounds. On a spring day in 1983, 2 boys from a small Cappadocian village guided Miski along a steep dirt road to the slopes of Mount Hassan, where their family cultivated barley and chickpeas. Behind fieldstone walls that protected their plants from grazing livestock, the brothers presented Miski with several unusually tall Ferula plants with thick stems that exuded an acrid-tasting resin. Miski's subsequent research revealed that only one other specimen of this plant had ever been collected, in 1909 at a site 150 miles to the east of Mount Hassan, and was subsequently identified as a new species, Ferula druidiana. Miski's conjecture that Ferula druidiana would yield a chemical gold mine proved accurate. Root extract analyses identified 30 secondary metabolites, substances that, while not directly involved in plant growth or reproduction, confer selective advantages. Among these compounds, several exhibit cancer-fighting, contraceptive, and anti-inflammatory properties, including shiobunone, which interacts with the brain's gamma-aminobutyric acid, GABA, receptors and may contribute to the plant's intoxicating aroma. Miski anticipates future research revealing the presence of numerous yet-to-be-identified compounds of medical significance. The same chemicals are found in rosemary, sweet flag, artichoke, sage, and galbanum, another Ferula species, the professor marvels. It's akin to combining several crucial medicinal plants into a single species. Evident medical potential. Ferula druidiana exhibited clear medical potential, but it was only during a return visit to Mount Hassan in 2012 that Miski began to draw parallels with the Sylphian plant he had read about in ancient botanical texts. The young caretakers of the Ferula plants informed the professor that sheep and goats grazed on its leaves, which reminded him of a description in Pliny's Natural History of sheep being fattened on Sylphian. Miski also observed that after being drawn to the pearl-colored sap, flying insects commenced mating, prompting him to recall legends that celebrated the ancient plant's aphrodisiac properties. In a 2021 publication in the journal Plants, Miski elucidated the similarities between Sylphian, described in ancient texts and depicted on Cyrenaican coins to commemorate the region's most renowned export, and Ferula druidiana, thick, branching roots akin to ginseng, frond-like basal leaves, a grooved stalk ascending towards extravagant circular clusters of flowers, celery-like leaves, and papery fruits, or mericarps, resembling inverted hearts. The striking resemblance in appearance was not the sole compelling connection. The original Sylphian was said to have appeared abruptly, following a significant downpour. Miski observed that, when rains arrived in Cappadocia in April, Ferula druidiana would emerge from the ground, growing up to 6 feet in just over a month. Due to its resistance to cultivation, ancient Sylphian was harvested in the wild, a task entrusted to desert nomads. 2 attempts, as reported by Hippocrates, to transplant it to mainland Greece were unsuccessful. Miski also encountered difficulties in transplanting Ferula druidiana. It was only through the application of cold stratification, a technique involving the exposure of seeds to wet, winter-like conditions, that his team was able to propagate the plant in a greenhouse. Since the early 19th century, 3 contemporary species have been proposed as potential candidates for the long-lost Sylphian. Ferula tingitana, commonly known as giant fennel, bears a resemblance to the plant depicted on Cyrenaic coins, and its resin is utilized as a folk medicine in Morocco. However, its high ammonia content renders it virtually inedible. Cacris ferulacea possesses heart-shaped fruits and produces a pleasant scented resin, but its leaves do not align with the ancient descriptions. Furthermore, it is a prevalent plant in Italy and Greece, contradicting the accounts of ancient sources that indicated Sylphian did not grow in those regions. Margotia gamifera exhibits a striking resemblance to the images on coins, but its range, encompassing northwest Africa and the Iberian Peninsula, does not match. Additionally, its stalk is too slender, and several studies have concluded that it possesses minimal medicinal value. Morphologically, Ferula druidiana appears to be the most probable candidate, asserts Shaina Gazanfar, a research associate specializing in the taxonomy of Middle Eastern plants at the Royal Botanic Gardens at Kew, London. The striated stems, fruits, and potentially the root all suggest that this Ferula species may be a remnant cultivated plant in Anatolia, formerly known as Sylphian. Gazanfar highlights the distinctive arrangement of the leaves on opposing sides of the stem. The opposite leaves, which are absent in other species, are particularly compelling evidence. A distant survivor? While Ferula druidiana aligns more closely with ancient descriptions of the Sylphian plant than any other proposed species, there remains a challenge. Ancient accounts were unanimous in stating that the finest Sylphian originated exclusively within a narrow zone surrounding the city of Siron, a site now occupied by the modern settlement of Shohat in Libya. The foothills of Mount Hassan are approximately 800 miles northeast, as the crow flies, across the Mediterranean. During his presentations at conferences, Miski underscores the fact that the plant has been recorded in 2 locations in Turkey, both of which had historical Greek populations dating back to antiquity. Last October, Mehmet Atta, who as a child guided Miski to the orchard where the plant thrived, led us to a nearby village and showed us his childhood home, which had been abandoned. The dwelling consisted of a network of dimly lit rooms carved directly into volcanic rock. Atta, now a grandfather, explained that his family had acquired the property sometime after the 1923 expulsion of Greeks from the region. Prior to this, the village had been inhabited by Cappadocian Greeks who had resided in villages in central Anatolia since the time of Alexander the Great. Miski speculates that approximately 2,000 years ago, a Greek trader or farmer attempted to cultivate Sylphian seeds that had been dispatched to him from North Africa. Given the 10-year maturity period of the plant, it is plausible that it was initially planted by farmers but subsequently forgotten. The plant continued to grow in its natural habitat and eventually populated a small area. The descendants of the original farmers would have been unfamiliar with the plant. Erica Rowan, an associate professor in archaeobotany at Royal Holloway University of London, finds Miski's speculations plausible. She points out that the ancients were adept at transporting goods. There is no reason why individuals from Cyrenaica could not have transported the seeds to Cappadocia and planted them. The plants share similar characteristics, including a Mediterranean climate, and the Ferula species depicted on coins bears a resemblance to the plant. However, Alan Tuwade, a historian specializing in medical plants of antiquity, expresses skepticism regarding Miski's theory. He questions the assumption that the plant is exclusively Greek based solely on the presence of Greeks in the region. Wade argues that Miski's team would strengthen their argument by identifying specific compounds in Ferula druidiana that possess similar medical properties to those attributed to Silphian. The primary challenge lies in the fact that ancient authorities prescribed the plant for a wide range of ailments. Silphian was believed to cure baldness, dental pain, pleurisy, epilepsy, and even served as a balm for both dog-bitten and scorpion-smitten individuals, as described in a lyrical translation. The definitive confirmation of the identity of the plant can only be achieved through the discovery of ancient plant remains for comparative analysis. Lisa Briggs, a postdoctoral researcher at the British Museum and National Geographic Explorer, suggests that archaeological sites such as the Libyan seaside town of Susa, the island of Malta, and the Greek port of Piraeus could yield valuable insights. A recent paper she co-authored recommends these locations as potential sites for the excavation of shipwrecks that may have sunk while transporting Silphian. The culinary Holy Grail. In the absence of a well-labeled jar of Silphian being retrieved from the depths, the majority of experts concur that there exists a promising yet uncertain method of supporting the notion that Ferula druidiana corresponds to the Silphian of antiquity. Someone would have to consume it. Its medicinal properties were of significance to the ancients, but Silphian's defining characteristic was that it was a seasoning, explains Rowan. Unlike classical medical texts, which tend to be imprecise in their details, the cookbooks that have survived from antiquity are frequently explicit regarding quantities and techniques. The most renowned, a handbook of 475 recipes that attained its final form in the 4th century AD, is known as Apicius, after a renowned gourmet who resided during the reign of Roman Emperor Tiberius, AD 14 to 37. Numerous recipes within the compilation specify Silphian in one of three forms: pure gum resin, referred to as laser vivum, resin mixed with flour, laser piscium, or the dry root, Lacerus radix, which is typically cut into pieces and crushed in a mortar and pestle with other seasonings. For Sally Granger, a researcher who co-edited the authoritative English translation of Apicius, discovering the original Silphian and experiencing ancient recipes anew with it is akin to a holy grail. Granger, who previously held the position of head pastry chef at London's Athenaeum Hotel for 5 years before pursuing a degree in ancient history, demonstrates Roman cooking techniques on her A Taste of the Ancient World YouTube channel. Until now, she has recreated recipes calling for Libyan Silphian using a lower quality substitute mentioned in Apicius, Parthian laser, which is believed to be asafoetida, a resin derived from another Ferula species that thrives in Afghanistan and is utilized in contemporary Indian cuisine under the name hing. When the original Silphian became scarce, Roman chefs resorted to the more affordable and abundant asafoetida, and Apicius clearly distinguishes between the refined Libyan plant and its more pungent, sulfurous eastern counterpart. On a sunny May morning in Istanbul's Nezahat Gökçeada Botanical Garden, Turkey's most important repository of plant biodiversity, Professor Granger and Chef Miski convened at a makeshift outdoor kitchen to ascertain whether Ferula druidiana, a plant of immense culinary significance, could indeed be the holy grail of culinary history. Professor Granger had recently returned from the foothills of Mount Hassan, where Atta had been diligently monitoring the plant's development. The abundant snowmelt had provided ample irrigation, transforming the field into a vibrant tapestry of brilliant yellow flowers. Ferula plants in full bloom signaled the optimal time for harvesting the roots, which were at their peak pharmacologically active. Professor Granger had embarked on a journey from the United Kingdom, equipped with mortar and pestle, as well as all the necessary spices and condiments to recreate recipes from Apicius, including sweet wines, the fermented fish sauce garum, and herbs such as rue and lovage. As terracotta pots simmered over charcoal braziers, Chef Miski presented the professor with a thick, ridged stalk of Ferula druidiana, exuding pearl-colored sap from a freshly cut surface. Professor Granger meticulously collected a lump of hardened resin from the plant and dropped it into a pan of heated olive oil, initiating the preparation of lazaratum, a simple Silphian-based dressing. A captivating aroma permeated the air. "It is an intense and delectable scent," remarked Professor Granger. "Upon inhaling it, one's saliva is stimulated." As picnic tables filled with plates from Roman recipes, each with a version flavored with Ferula druidiana and one flavored with Silphian's ancient replacement, asafoetida, a crowd including the Botanical Gardens directors and staff and Miski students gathered around for samples. A bowl of Alita lenticulum, lentils made with honey, vinegar, coriander, leek, and Ferula druidiana, was deemed complex and delicious, while the same dish made with pungent asafoetida resin elicited grimaces and was largely left untouched. Squash sautéed with the plant's grated root was also consumed with gusto, as was a delicate dish of prawn dumplings referred to in Apicius as isisha, dipped in the lazaratum sauce. The most significant success, however, was Ias in Wifero fervens, a sauce for lamb made with sweet wine and plums spiced with an ample dose of Ferula druidiana. "It's beautiful," exclaimed Granger, as she rested in a lawn chair after a long day on her feet. Even though the sauce is rich and dense, the flavor of the Sylphian is not overshadowed by the fruits and spices. It possesses an intense green flavor that actually enhances the qualities of the other herbs in the sauce. A version made with asafoetida was excessively pungent. It was evident that Granger held great gastronomic merit for Ferula druidiana and believed it to be a suitable candidate for the long-lost plant of the Greeks and Romans. Miski appeared pleased with the outcomes of Granger's experiments, albeit surprised by the taste, though he confessed to being concerned about the potential implications. "There are only 600 individual plants we are aware of globally," he pointed out. 300 of them are found in the wild. An equal number are now being cultivated from seed in the botanical gardens, although it will take several years before any of them are mature enough to produce fruiting bodies. You would need to cultivate 1,000 times as many plants to produce a commercial supply. 2 millennia after the original Sylphian supply was depleted, the legendary plant may have re-emerged only to encounter a formidable adversary, human consumption. Currently, the population is so low that Ferula druidiana officially qualifies as a critically endangered species. "That is what concerns me," expresses Miski, his voice laced with genuine alarm. "If everyone begins preparing Sylphian sauce, we must act quickly to prevent a shortage." Kindly subscribe to the channel, share it freely, and leave your comments in the designated section below. Thank you for your attention.